Okay, so today I'm going to cover a little bit of network. Um, this is no way means I'm covering anything deeper in network, but for the understanding, this is a little bit I have to cover. And let's see here. So the biggest part of the infrastructure is, besides servers, is a network because one server need to communicate with other servers or outside world. So that's where the network is. So basics of network is anything which is in an infrastructure is considered a network. It could be any desktop computer, laptop, servers, um, switches, routers. All these are part of network. Okay. So, but I'm not going to go deep any of those, but I'm going to cover a little bit so that we have some basic understanding, and then we're going to cover the communication type UDP and TCP, how the UDP and TCP works, and those are the only things we need to worry about. Okay, so everybody knows or came across, when you don't have a network connection, first of all, what you're going to do is you're going to see if there is any the Wi-Fi is there or not, or the cables are loose or something. So because you want to make sure the network connection is there. So I'm going to talk a little bit about NIC. NIC is the one that we were playing around yesterday. Um, so we have in this computer we have two physical network cards, ETH1 and ETH2. Okay, so ETH. Okay, this is the one we are looking at. This is virtual here. In reality, there is a physical network card. Okay, so let me, if I could find the image. Okay, so I found one image for this here. I can't paste.
Did you snip it, Joseph?
Yeah, yeah. So this is a network card, and okay. So the network card, what's essential for network card is, I mean, it's an electronic device. It has a lot of stuff, chip and everything. But on top of that, what it has is it has a MAC address. Uh, Actually, the correct term for that is the hardware address. Okay, so this is an example of a hardware address. It's an alphanumeric number. Okay. So what this number is, all these numbers means some kind of information in here. The all if you run this number, you will have who manufactured it and all that, and the serial number. There's a lot of information which is coded in this number here. So we're not worrying about that.
It's always hexadecimal, Zafar.
Yeah. So this is a hexadecimal, and these when 08, these are not actually when B0 is not actually B0. It's different number. But we're not worried about that. And this is hard coded. This is hard coded into the NIC card. What does it mean? Because this number cannot be changed. Okay, the IP address might change, but this number won't change. So if security is tracking this number, they will track using the MAC address, and there is no way in the world that the MAC address will change. And all the trails, all the tracks, it has a MAC address trail in there. So this is what the MAC address is. It never changes, and it's built in. And then so and then this MAC address in combination with the IP address. So it has IP address. Okay, within that there are two kind of IP address. One is IP version 4 address, IPv4, and IPv6. IPv6. So the world is trying to move to IPv6, but it's not happening as much, as fast as it's supposed to be because we are running out of the IPv4 address. So what is the example of IPv4 address? The one we have here is the IPv4 address here, okay? This looks like IPv4 and this is the IPv6 address. If you are going to study networking, then all these things you will go like a deep dive and figure out what all these are about. But for us, we just have to worry about most of the time you will be dealing with the IP address a lot, and the V6 IPv6 they're trying to use it, but it's just not happening. Maybe they might use it for some security people might use it, but for us, for admins, we're not worried about that yet. But once it goes full-fledged IPv6, it's supposedly one of the greatest thing, I suppose.
Well, Zafar, for security research as a Linux admin, how much should we worry about spoofing of Mac?
Security is a different team, so you not have to worry about it.
Okay.
See, even there is on the servers, even on Windows and Linux, there is no security is installed like antivirus or the firewall. It's all disabled so that the internal network could work smoothly, and they don't have any blockages once everything is working. So the security is managed on the network level. Most of I've seen throughout my life is managed on the network level, and it's pretty good. But you never know, I mean, if somebody hacks in, they hacks in.
My question was that this machine address, sometime if it is spoofed, the address which we are seeing, it may not be the real MAC address, right?
Honestly, I couldn't tell you for sure if it's being spoofed or not. I mean, to me, security is a totally different thing, and usually you don't get to see security people as much unless you log into some servers you're not supposed to and you get a call. I mean, there are a lot of things. I mean, security is in itself is very, very deep. Usually, you have to be a network admin and then a little bit of Unix admin before you go into security.
Okay.
So, I mean, I couldn't answer some of your questions, but I think you have good understanding of how things are working. So, okay, so this is all about Nick here. I mean, there is a lot to it than what I'm showing here, but this is just what you just have to remember is this is a network card, and it has a hardware address. It cannot be changed, and it has two kind of IP address, version 4 and version 6. This here is automatically giving the version uh, IPv6 version, even though even though I'm not asking for it, but it's doing it. I think this is a Red Hat 7 feature, which I'm sorry, Red Hat feature, which is automatically assigning one. But if you really need to go deep into this, it's a lot more in. You have to learn a lot more on it. But as a network admin, I mean, as a Linux admin, you will be just working with the IP addresses. So far, I'm only working with version 4 IPs.
So based on experience, you haven't witnessed anybody in commercial.
I mean, I hear a lot that we should be moving them, but it's not just happening as they would like to. They are being used now, but maybe they may be using it for a very high secure environment. If they have like some financial data or something, maybe AIX boxes are using those. But day in and day out, you will be dealing with the IPv4 address all the time, as of now.
What I heard, they are changing the network infrastructure in Romania. They said they are moving to IPv6 now. Like all the networks over there, kind of be like they are trying to do it mandatory. So all the networks supposed to be on IPv6. Sooner or later, they're trying to move off the whole infrastructure there.
Where at?
Romania.
Romania?
Yeah.
All right. I suppose, I mean, they
No,
may
this is
have
like
chip
over.
hacking or something, so that's
Yeah,
why.
no, they said there's like a huge hacker gangs involvement over there. So they do a lot of defacement from over there. So there is no traceability. So they spoof the like IPs and MAC address. So now over there as a government, they said like as a protection way, they want to change the network to the IPv6. I mean,
Okay.
there was a whole big news about it, and it was a big article. So I didn't go through the whole thing, but I was just looking at it like what it's all talking about.
Yeah, yeah. I mean, once that's implemented, a lot of things will be a whole lot secure. But you never know. People who design it, they're gonna break it. So let's leave it there.
And more jobs as well.
Yeah.
That's true.
Well, don't worry. I mean, once you guys get this job, you're already into a high-paying job, then you could explore more options. I would definitely try to get like certifications and all this. But rest assured, once you get into Linux, you will be you all set at least for I would say for the rest of your life, you would be having at least good paying job for sure. And then you keep yourself updated. Every year you do something new. Okay, so this is Nick card here, and then let me talk about what are some of the basic things you need for network, basic requirements for a successful network. So what you need is you need a NIC card, and then you need media, and then you need topology, and then you need a protocol, and then you need an IP address. Okay, so uh, we talked about I think they should go up here. And then let's start. We talk about this, and we talk about media. Okay, media would be cables, Wi-Fi, and then yeah, cables and Wi-Fi would be media. But a lot of big corporations, they're not using Wi-Fi because it could be hacked still. So you still be running everything on the hard cable. Okay. All right. And the example of cables is we have RJ45. If you look on the back of your computer, the cable which is connecting into network card it's called RJ45. Okay, the one for telephone is RJ11. Nobody's using it, right? Let me just remove that. And there are two categories of RJ45, Cat 1, Category 5, and Category 6. So these are just like how the cables are arranged. That's what it is all about. Okay. So what is the next one? Topology. Okay, so topology is nothing but how the communication or how the network is set up. Okay, so what does that mean is in the old days they don't have much choice to work with only single kind of topology. Okay, so I'll just briefly touch on that, then we'll move on. So in old days, what they used to do is they used to have a ring topology. Okay, ring topology. And what does that mean is it has all the, oh man. Okay, let me find a picture for that. Ring topology. Okay, this is exactly what the computer used to be in the old days. That a communication is going from one computer to another computer to another computer. So if it need to send information from here to here, I'm sorry, from this computer to this computer, it has to go through the ring. And if something is broken, if this computer is down, there won't be any communication. So you could obviously see this is not very useful. So then later on, what was developed was another technology called bus technology, topology. And let me find a picture for it. Okay, so this is an example of a bus topology. So what's happening here is you're not dependent on one computer. If that computer goes down, you will still be able to make communication here. So if you want to send something from here to here, it goes here to the main cable, and then it goes to this here. So similarly, the same way. But this is just not the cable. It has more stuff in the middle, but we're not going to cover that. Okay, so let's quickly move on to the next one I have here is star topology. Let me find a picture. Okay, now you could understand this is much more efficient here. Okay, so what it has now in the middle is all these computers are independent of each other, and then if you want to send something from here to here, it goes through this main switch, and from there it gets routed to the intended target. Okay, so I'm not sure if this is being used as much. If you just have a switch in your home, you could relate that to as a star topology. Okay, but the moment you have more than one switch or more than one router, it becomes a mesh or tree. Mm, okay, I found one image. Okay, so this is an example of a mesh. You could obviously see they are interconnected, and one computer is connected to all computers somehow. So that way there is no redundancy, and there is no downtime if the computer goes down. Okay. All right. Good. Let me see if there is another one here. Tree. Okay. So there is another last one is called tree, and I think this is most infrastructure is based on these days. Is it has a lot of computers, a lot of switches, networking gear, and everything. All these are all this is considered a tree topology. So I'm not sure about mesh if it's being used as much, but I know for sure any big corporation they are doing a tree because they have routers, switches, and all this in their environment. Okay, let's see here. So we covered NACARD media topology, and then we are worried about protocol here. Okay, so what is a protocol? Protocol is it defines how things are being communicated. So when it comes to the network, it defines how things are being communicated. So there are a lot of protocols out there, but I'm going to just focus on the OSI model here. There is one network specific protocol. It's called OSI. So in network, there is a model called OSI model. Okay, OSI. OSI layer. Okay, what it stands for is open source, open standard. Okay, if you're going to learn into Cisco or something a lot more deeper, this is what you're going to run into. What this is this is a protocol layer that has been defined uh, by I think by IEEE. There is a society IEEE. They are the one who came to the standards and defined how what all these things going to be working. So this is comes into a protocol. Okay, so there are 7 layers. Okay, 7 layers to this. 7 layers of OSI. There are 7 layers of OSI model. Okay, so what are they? The first one is physical layer, and then the second one is data layer. Third one is network. Fourth one is transport. Fifth one is session. And the sixth one is a presentation. And seventh is application. Okay, so in physical layer, you could imagine this is considered this is where the hardware is at. Physical layer is a hardware layer, and then whatever the data is being generated between the hardware and the application. This is what the data layer is. Okay. Okay, and then this is a network layer. Obviously, all the network works here. Switches and routers. Okay, and then the transport layer. This is how the communication is being done. Session layer this is where the session is established between two computers. And then the presentation layer is okay. This is where data is being presented to application. Okay, when you receive a Word document, the data is for the computer. There is no difference between Word document and text document or a text message, anything like that, because for computer those are all zeros and one. Those are all binaries. So when it gets into the presentation layer, the data, then the application realizes what kind of data, and then that application will launch. So if you get like a Word document, you click on Word document, that application associated with that kind of file. For example, if it's a Word document, Microsoft Word launches. Okay. Okay, so these are all the layers here, but we're not worried about all this. I mean, I'm going to show you a little bit of transport layer because we will be doing some troubleshooting how the communication works on it or not. So let's focus on transport layer. Okay, so you guys heard about TCP and UDP, right? Anybody heard about TCP and UDP?
Yes.
Okay, okay, great. Okay, so within transport layer, there is a protocol called TCP. TCP. So what is this transport control protocol? So what this protocol does is it goes through the OSI model, but it's not using all um, all layers of OSI model here. I'll show you how. Okay, let me put this thing here. So TCP is using about four layers of OSI model here. So which one is it using? It's using data, and it's using network, and it's using transport and application. So it's using these layers here. Okay. So how is the TCP communication being work? What does TCP does is TCP is actually a very secure type of a protocol.
But there shouldn't be otherwise that TCP is built on first three layers, right? So it is using the network data and physical layer.
No, I mean it's been there, but this is what it's the TCP is based on: data, network, transport, and application. Okay, so this is the data. Data is being generated, then it's being transported to the network layer, and then from there it gets transported, and then all these things are there, but the TCP is not making any connection until it uses the application layer. Okay, I mean, it doesn't make sense just keeping two in here in the middle, but that's how it's working. So from one computer to another computer, this is a transport control protocol. It's making a connection here. So let me show you how. Okay, good. So what does TCP does is TCP makes a three-way connection. TCP makes a three-way connection. Okay, let me find a picture. TCP. Okay, I found one image here. So TCP does a three-way connection here. So I'll show you how. Okay, give me 1 second. Somebody's texting. Okay, so what happens here is when any packets are being sent over the network, it makes a three-way connection between the two hosts or two computers here. How is it going to do? What it's going to do is it's called a handshake. This is called a three-way handshake. Three-way handshake. So what happens is when there is a TCP communication going from here to here, what it does is it makes a sync connection. It makes a sync connection. Okay, so from A to B, it's sending a sync signal. Sync signal is sent. Okay, so what B does is then B to A, what B is doing is it's sending a sync signal also, and then acknowledging the signal, the very first signal the A sent, it's acknowledging it. It's syncing and acknowledging at the same time. Okay, then what A does is A acknowledges too. A acknowledges that it received its sync and acknowledgement. Then the data is transferred. Then the data is data is transferred after the three-way handshake is successful. So this is called a three-way handshake, and this comes under TCP protocol here. I mean, you don't have to worry about too much here, but in the interview they will ask you, how is TCP connection established? All you have to do is say sync ACK. So what you have to remember is sync SYNC sync, then sync ACK, and then ACK. So sync stands for sync, acknowledgement stands for acknowledgement, and ACK stands for acknowledgement. Okay. Any questions so far? Okay, so this is a three-way handshake, and it's called establishing connection. Okay. So here the computer is sending you, let me see if this is correct information here. So on here it's sending, it's listening here. The computers are always into the listen mode, okay? They are always listening something. That means is waiting for data to be received. So if a computer sends a sync signal to this computer here, and it received a sync, and then it acknowledges the sync here. It says, okay, I received your sync and I'm acknowledging. So it sends it here, and then computer A says like, okay, I did receive your acknowledgement that you received my first sync, and then that's how the connection is established. One way, two way, three way. Okay. The picture is correct. What is showing in the picture and what I have put down here, they both are matching. Any questions?
So the way you show us the putty actually. So is that a good example?
Yes, that's the best example.
Okay.
All this is happening at you're not even realizing how fast it's happening. So putty is the best example. Okay, so this is how it's the connection, establishing a connection. Okay, so closing the connection, how is it being used? Okay, so let me find a picture for you. All right, I think I found something better here. Okay, this picture is much better. Okay, I like this picture. I'm looking for closing connection. Okay, hold on. Okay, I have a hand drawn. Okay, so
Mr. There's a similar picture which you copied the exact same two blocks and server and client on
you
the
found
same
it
page.
online?
Yeah,
Can you put it in here in the chat?
yep. It's basically if you search Google image closing TCP connection and it has exact which you TCP states posted, same server, same client, and same two boxes, and just one more arrow. Let me paste link in the chat and you can do that.
Okay, I think I found it.
Okay.
Yeah, thanks. That's a good one.
Yeah.
This one, right?
Yeah, yeah.
Okay, great. So this one similarly works as the same thing. And so what it does is it sends a signal that it's done. It sends a signal saying it's finished. So okay. So it sends a signal which says which server one, when it's done sending the data, it sends a signal. It says finished. What A to B, it says it sends a signal, I am done, I am finished. So it sends a signal fin, F-I-N, stands for finish. Okay, then what B does is B to A, it says I acknowledge that I received finish signal. Okay, acknowledge to finish signal. Okay, and then what A to B goes again. I acknowledge that you acknowledge that you received a finish signal. Okay. Okay, that's how it is.
But Zafar, I think the client understands one signal, but the server responding two signals back.
Yeah, the server responding with two signals back. B is always responding twice.
Okay.
And then A is on the last one. The A is responding that I acknowledge that you have acknowledged. Sounds silly.
Look.
Okay, so for short, it's called FINAC ACK. Okay, FINAC ACK. Okay, so this is a three-way connection here. So one way, two way, three way. Okay, you get the idea. I mean, there's a lot more to it, but I'm not doing too much on it. It's just the little concept here how the TCP connection is established. Established is doing the same way, three way, and closing it is also using three-way connection. Okay. All right. So you will be using a utility called TCP dump. I'll show you later in the class to make the connection. For troubleshooting. For troubleshooting, you will be using TCP dump. TCP dump is a little utility uh, to check connection. Okay, so what will happen is when there is a network problem and there is no or network is unstable, you will get a call from network team and that you need output for the TCP dump, and you will run that output and give them the output here. All you're doing is just run it and then give the file to them, and they will analyze it and then they'll work furthermore on it. Okay, all right. So I got covered everything here. So let's see here if there is a command called netstat. You type netstat. Okay, so these are all the ports which are active right now. It says connected. Well, so I'm going to type netstat hyphen ANP. ANP stands for all network port, and I'll grep for hyphen W22. Okay, so if you have noticed a little bit on the putty here, we always connect on port 22, and this is a SSH port. These are all different ports here. If you want to do serial, the port number is 9600, and the raw doesn't have any. Telnet is running on 23. Our login is running on 513 and SSH. To be honest with you, I never used any of these other things here. I always have used SSH, which is port 22. Okay, so what happens is on a very high secure environment, port 22 is a SSH port. The whole world knows that. So what security people does is they'll change the port, the SSH port. They'll shuffle around, and then they will let you know if you need to work on it. What's the port number SSH is connected. This is by default. Any operating system, Windows or any operating system that's running, it has the default SSH port is assigned to port number 22. And how many ports? How many ports the operating system has? I think it has about 65,000. Okay, yeah. Okay, so your Red Hat has about 65,535 ports. These are all open ports. These are by default they are closed, all of them, but only few are open. But our operating system has these many ports here. So you could imagine there are these many small applications. Even if you come up with your own application or something, you could end up describing which port your application is going to start communicating on. Okay, so we're not worried about that too much because most of the Red Hat environment is pretty secure, and only the known ones like SSH and all those are open. Okay, so to see if your port is on and listening, you type a command nested hyphen apn and then grep for listen. Okay, these are all the ports which are open right now. Okay, here's port 22. And there's another port apparently SSHD. This is a daemon running on this port, and it's using the port 22. Okay, and let's see here. Okay, it's running twice, I suppose. And all these things, you will get to learn what the port numbers are, how to block it, and all those things. If you are a little bit on the security side, you will work on that. But for admin, you're not worried about that too much. You're mostly worried about port 22 and some other ports that I will cover later on. Okay. So these are the commands you would see if the port 22 is open. You will get this prompt here. Okay. If it's not open or if you cannot connect or there is some problem having, the very first thing you would see is ping. If you don't ping it, then you want to see if it's the port is open or if the port is blocked, some kind of problem is having. I mean, the important thing is you just get the concept how things are working, and most of the other times, if you get stuck here, you would talk to people at work. If not, then you put in Google and start working that way. Okay. If you get any problem, anything, and somebody want to work on that right away, you just say, okay, let me work on it. You just don't try to say I don't know or anything. Let me work on it, and then you get back to them. That's all you say.
Another question.
Yeah.
So are these ports in the operating system, in the configuration, like in ETC? Where are they? Where are they? Somebody wants to see them.
Oh, the ports. Okay, so what happens is that these are all the known ports here, but when you install an application, with that application, the port is will come up here. But let me show you. Let me show you how would you check the at least for port 22. Okay, let me see. Uh, I think I have here. Port. Okay, so let's see here. Okay, right here, this the SSHD config file. It has a port 22 in here. So you could come here and then you could change this port 22. You could change it to something else. Give me 1 second here. Okay, I'm gonna change it to port 222. And let's see if it's gonna work. Okay, I exited out of it. And let me see here. Let me load this.
I think the line was commented for the way. So
The line
how
was
it's gonna
committed
work?
out, right?
Yeah.
Oh, okay, yeah. Um, oh, okay, I think it's here, right? Let me. Okay, let's see here. I normally don't do this. Maybe it's no.
So Zafar, have you changed and tried,
Yeah.
and it didn't work?
No, it didn't work. It's working on 22 still. Uh,
Did you restart? It might need to restart.
no, I restarted the service, right? SSHD. No, there is no such thing as SSHD is the service. And let me see. VISSH underscore. Hmm. Interesting. Protocol. Okay, let me get back to you on this one here. For now, we'll just work through what we have here. But yeah, there are many ports here. That port, I mean, there is no easy way to see those ports here. But when you install the application or whatever that port is running, it connects with the kernel. It connects with the kernel, and whatever that application is, it establishes a port at that moment. So when somebody is hacking, what they try to do is they exploit the known ports and try to install the little application. It's only like four or five line code. They try to they try to install that using the known ports, and then they open up the port, whichever port they like. So so once the system get hacks, it's going to be really difficult to pinpoint which port is being used to exploit the system. So those things are much more into towards white hat. If you're working into security and all those are really advanced things here. I myself want to learn those, but those things, unless you're actually doing the job, you're not going to be able to uh, get all that in the environment here, unless you're working through the security. Okay, let's move forward.
Well, actually, Zafar bhai, the file you just try to edit and try to put the port 2222, that was the right spot, but you have to just
Uncommented? Hello? I cannot hear you. Are you there? All right. Okay, so we are going to mostly work on the port 22. That's the communication port for SSH. Okay. Okay. All right. So we are done with TCP. Now another protocol that's being used is called UDP. Okay, UDP protocol. So what this is a UDP protocol is, it's a user datagram protocol. Okay, so what, okay, by the way, for TCP protocol is known for connection. It's known for connection established protocol. Connection protocol. Okay, what does it mean is it's transferring the data after it's making or establishing a connection here. But UDP is connectionless. Okay, what does it mean? What it means is it just sends the data to the receiver without confirmation. Okay, and this makes it faster. So if you're just throwing out the data and you don't care if somebody gets it or not, it's called UDP connection. Okay, let me find a picture for that.
Zephyr, quickly, isn't UDP unsecured and TCP is secure?
Yes.
Yeah. Okay.
But no, UDP is not receiving anything back. It's just throwing information out there.
Yeah.
So in other words, it's just called a broadcast. It's known as a broadcast. So this is how the communication is being done. There is a client here, and then it just sending data out on the network, and it doesn't care who receives it or not, or there is no confirmation. Okay. All right. So this is not much deeper into is no means this is any of a real network. I'm telling you anything about. There's a lot of things and there are a lot of gaps here, but this is just the basic understanding you should have. And then I have a chart here that there's the difference between the TCP and UDP. Okay. 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 I just have to type it up. Okay, this TCP. Sometimes you get interviewed in the question here. I'm sorry, you get questioned in the interview. So you just have to remember these. Okay, most of the time you will be quizzed. Oh, what's the difference between TCP and UDP, and also how the three-way handshake is established. So if they're not asking how the three-way handshake is closed, if they say how the three-way connection is established, you just say sync, ACK. Okay, and if they specify how is the connection closed, you just say fin, ACK. Okay, all right. So very first thing I have here is TCP and UDP. It's a connection-oriented protocol. And the UDP is connectionless. Okay. And then the second one I have is the TCP is reliable. You could obviously see because it's getting confirmation and everything each time. And this is unreliable. Okay, and this is slow. And this is fast. UDP is fast. And some of the example is HTTP, FTP, SMTP. All these use TCP. Okay, and then UDP, example of UDP is DNS, DHCP, and a broadcast. All these are examples of a TCP and UDP. Okay, you will definitely be quizzed at least on TCP. They will ask you if the TCP is a connection or connection oriented or not, and you just say yes, it's a connection oriented protocol. Okay, good. Okay, so Now, what I'm going to show you is I'll show you the TCP IP. This IP address, where is this? I don't see IP address anymore. Right here. Oh, okay, it's bound. So I'm going to show you this IP address is not what you see, but the computer uses this as in binary. So I'll show you how to decode that, okay? So we're going to take the example of what we have here, and then we're going to do our calculation how this number is actually not what you're looking at in a binary, okay? So I came up with one table here. Okay, so let me just bring up the table here. So what the very first one is 2 to the power of 0. Okay, for a computer system, 2 to the power of 0, what it means is, for the system it means 1. Okay, and for the system, if you say 2 to the power of 1, it means 2. Okay, similarly, we're going to go up until 2 to the power of 7, total of 8. 2 to the power of 2 to the power of I'm sorry, 2 to the power of 2. Okay, so what is 2 to the power of 2? Is 2, 4, and 2 to the power of 3. 2 multiplied 3 times. So 2 multiplied 3 times is 8.
8.
And then 2 to the power of 4 is 16, and 32. 4, 5 is 32. Yeah, and 32, and 2 to the power of 6 is 64, and 2 to the power of 7 is 128. So the network, what network does is it uses this kind of formula here, and it goes up to 128 bits. I may not be using the correct term here, but this is what it looks like here. So when you do 2 to the power of 0, you're going to get 1. 2 to the power of 1, you get all these numbers here. It goes up until 2 to the power of 7 here. In total, it's actually going 8. If you count from 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's actually doing 8 2 to the power of 7, but it's actually 2 to the power of 8. I mean, not exactly 8. 2 to the power of 7. Let's just stay there, okay? So how is this IP address being calculated by the system here? So let's see here. Let's copy this here. Let me make a few more boxes here. Let me make 8 boxes here. Okay. 128 and 64, 32, 16, 8, 4, 2, 1. Okay. So we have our 192. So we have our 192. What we're gonna do is we're gonna remove. Okay, hold on. Let me. So is 128? Can we remove? Can we subtract 128 from 192? And then yes, we could do that. Okay, so let's let me keep my calculator handy here. So I have 192 minus 128. Okay, so I have 64. No, 192 minus 128. So I have 64 left. Okay, so what's happening here is I'm calculating here. If 192 can be removed, 128 can be removed from 192. If that is true, I'm placing 1 there. Okay, so what is left here? From here, so 64 is left, right? So I'm going to type 64. Can 64 be deducted from 64? Yes. And what is left is 0. So if I'm able to subtract the number from there, then I'm going to put 1 in there. Okay? And now what is left here? 0. So am I able to deduct 0 from 32? No. So all this is going to be 0. All these are 0. So all these fields are 0, 0 for me. Okay, so we calculated 192 equals 1 1 and then followed by 0 0 0 0 0 0. This is what exactly 192 means. This is a binary number for computer. If you give the number 192 to the computer, this is what it's writing on the deep down on the kernel level. Okay, and this is true even if you are running Windows, any other computing system you're running. This is what is called binary. Okay, let's take a look at 168. Okay, let's see. Let me copy this. Okay, so I have 168. I'm going to remove 168. I'm going to remove 128 from 168, okay? So I got 168 minus 128. What is left is 40. So if I'm able to subtract, then I'm placing 1 there, okay? And then what is left? 40, right? 40 minus 60. I'm not able to subtract that. So I'm going to leave this field 0. Okay, now I'm going to come here, 40 minus 32. Am I able to subtract something from 40 minus 32? Yes. So I'm going to place number 1 there and then move on with the remainder here. Okay, 40 minus 32, 8 is left. Now I'm trying to remove 16 out of 8. I can't do that. So 0. And then I'm going to forward 8 again. 8 minus 8, yeah, I'm able to do that. So I'm going to place 1 there. Okay, and 0 minus 4, I can't do that. So 0 is left, minus 2 is again 0. And 0 minus 1, I can't do that. 0. So now 168 is, what is 168 for the computer? 1 0 1 0 1 0 0 0. Okay, let's play with 56. What is 56? Okay, great. Wow. So you are removing 56 minus 128. This is not going to work. So 0. I'm placing 0 in that field. So I'm carrying over 56 again minus 64. That's not going to work either. So now 56 minus 32. That is going to work. So I'm going to place 1 there here. Okay. So let's see. 56 minus 32 is 24 is left. So 24 minus 16. And then I am using that field, so I'm placing a number 1 there. So 8 is left. 8 minus 8. I'm using that field also. I'm going to place number 1 there. And the 0 is left. 0 minus 4. I can't use that. So it's 0. 0 minus 2. I can't use that. 0. And 0 minus 1. Again, I can't use it. So 0. So for computer, the number 56 is 0 0 1 1 1 0 0 0. Okay, and if you think this has zeros in front of it, let me just delete the zero, it doesn't mean anything, then everything changes. You have to put leading zeros in there. Okay, so what is left now? 110. 110. Okay, let's play with 110. Okay, so I have 110 minus 128. It's not going to be a good result, so I'm going to put 0 there. 110 minus 64. Yeah, that's going to work. So I'm going to put 1 there. You guys are following so far, right? So 46 is left. 46 minus 32. So that is going to work. So minus 32. 14 is left. 14 minus 16 is not going to work. So I'm going to put 0 there. Okay, 14 minus 8, that is going to work. So I'm going to put 1 there. Now 6 is left. 6 minus 4. That is going to work. So then 2 is left. 2 minus 2 is working too. So I put 1 there. And now 0 minus 1 is there. I'm going to put 0. So 110 is 0, 1, 1, 0, 1, 1, 1, 0. Okay. So 192.168.56.110 is nothing but this number here. This number. Okay. Any questions? you will you're not going to be worried about this too much, but this is just a conceptual. You sometimes you may end up getting some request from security team and all that to give you the output, and you just have to calculate this and give this number out to them. Okay, so I have 15 more minutes. Anybody, any questions? Somebody was asking a question. Do you still have a question? Okay, good, good. Okay, so I'm going to show you how what default gateway is. So I have this hand-drawn picture here. What default gateway is nothing but the IP address of the router. That becomes a default gateway. Here, let's see here. So I think the one over here you're seeing here, 192.68.56.20, 255, this becomes a default gateway. But let me show you here. If I ping, most of the time, default gateway is the router, the IP address of the router here. So when you say default gateway, this is what the IP address is. So if I take this and then put it into the browser, so it should bring up the login. It should bring up the login page for the router here. Okay, this but what the router is doing is it's giving out the IP addresses. So let's see how the router works here. So we have two routers here. The moment you have two routers, it will become a different subnet. It becomes a different little networks in itself. Okay. So here this is a company network, and you have two routers here, router 1 and router 2. In the same building, you may have two routers here. So it becomes a subnet. So what a router does is it has its own IP, we just saw a moment ago, and then a router gives out the IP addresses. So it could give out how many IP addresses it could give out. An average router could give out. Router gives up about 255 IP addresses. Each subnet, and one IP is reserved. One IP is reserved for router itself. And it is a default gateway. And default gateway is entry point of the network to communicate with other networks. It's pretty simple. If you go out and buy another router in your house, you have like two routers in your house. The moment you put two routers in your house, it becomes a subnet, sub subnetwork, and then you could put it together to a cable modem, and you could have like two networks in your home. So it's just that simple here. But the moment you add a switch, a switch is nothing but adding an extra ports to the router here. So switch doesn't do anything. It just extend how many ports a router could have. So if you look at the picture of a router, it doesn't have all the 255 ports, right? Okay, so here's the picture of this little home router here. It's pretty silly. It has four ports in here. Okay, but an average router could give out about 256. I mean 255. So how is that you're gonna extend more than four? You just add a switch here. Okay, if you add a switch, so you add a silly switch here, so that you could extend plugging in more to your network. Okay, so but what's happening here is this switch is this switch it's not giving out anything. It's just a dumb switch. Everything is being controlled by the router. Okay, I can't paste it. So this is not a router, it's a switch because it's dominated by the router here. It's taking the instruction from the router. And this is a router. Okay, so if you want to have some communication from this server to another server, what it does is it goes to the router, and then from there the router establishes a connection with another router where that IP address is sitting, and that's how the communication works. It's not going to go directly from here. So if you look at the tree protocol, yeah, if you look at this tree picture here, if you want to communicate here to one of these from here, so from this host it goes to the router, and from there it goes to the main source. There may be other routers in here. From there the traffic is routed to the destination router, and that router receives the information and transfer it to the server here. Okay, it's pretty simple. I mean, the networking is pretty complex, but the diagram is simple, and the concept is pretty simple. But this is all we have to know for the Linux admin. So if you want, you could study a lot more. It's very deep and complex if you want to. But this is just the little informational, so that you're aware of all these things happening in the background. Okay. Okay, so let's see.
But Zafar, there is no charger for this router?
You could buy one. eBay, man. Okay. Yeah, there is charger. There is nothing goes on with the power. Okay, so right here, this is the command to see the default gateway. And this is where the default gateway, you would see that here. But since we have only host only adapter, but it should still show us the gateway. Destination.
Probably we didn't mention it in a bond file, I think. Yesterday we were playing with the file, we made it. So we didn't mention the gateway in that file.
No, but this command should bring up the gateway here. Okay, let me bring this up here. Okay, yeah, it's showing up here a default gateway here, right? So once you run this command here, the default gateway for this host is 10.0.3.2. Okay, default gateway is also, I told you, it's a entry point of a network, 10.0.3.2. Okay, it's working. I'm trying to go to that page for this router. It's not working because I think it's a cable modem. So I need to know the credentials. So anyway, if you want to know the default gateway of the network you're on, this should be 10.0.3.2. That's an example. But this is the default gateway for all the servers. If you have like about 200 servers in one subnet, all those subnets will have the default gateway as the same number. Every server you go to, and if you type in netstat-rn, the default gateway will be different, and the IP address will be I'm sorry, the default gateway will be same, and the IP address will be different. Okay. By the way, I got to show you an example of how the interface is on Red Hat 7 here. So let's go into, this is Red Hat 7 cd/etc/sysconfig network So in a Red Hat 7, the example is IFCFG ENP0S3. This is how the example is. We are using ETH0 and all that, right? So ETH IFCFG. So let me put this in here. Actually, I put it here. So these are only the silly. These are some of the silly things. There is a difference between Red Hat 7 and Red Hat 6. Okay, Red Hat's IFCFG hyphen ENP0S1. So if I have something like this here, I'll put the alert like that, Red Hat 7. Okay, good. Everything, if you run this configuration, what I showed you yesterday, everything should work. Okay. All these are same files and everything. This should be same.
Zafar, I have a question. Can we connect one virtual machine to another virtual machine?
Yeah. I'm gonna show you when we get there.
Okay. And then also, can you show us how to configure manually the default gateway? Or
Yeah, there's just a silly file. You just have to enter that in there. When we be doing DNS and all that, I'll show you that.
okay.
Okay, so I'm putting like this here, so you get the idea, right? When this is in red, that means it's for this is for Red Hat 7. Okay, I think I got it covered here. Any questions so far? I would say just to go over this a little bit once. It's just silly things. I never really go over this on my own when I'm working. So these are just something I thought you guys should know. So that's why I'm putting this together. But in interview, you will definitely be asked about this sync-ack. And I'll put all this, whichever one is good, going to be asked in the interview. I'm putting this in the, I'm compiling that list of all the things you will have in the interview. Like you go into interview questions, and I would highly recommend memorize this here, okay? For the interview, these are going to be really, really important. Okay.
All right, Zafar.
All right, I think we're out of time. So by next week, I think I'm going to start on FDisk and logical volumes and all those.
All right, Zafar. Thank you.
Okay, love it.
Love.
Uh,